In this section on file I/O, we'll talk about the different supported formats that we both can import or export in and out of Hoops Visualize. And what Visualize provides are format-specific classes to provide these capabilities. So the names of the classes correspond with the format. These are the names of all the different classes and the different formats. Some of these are self-explanatory, but to quickly go through them. The stream class is for the Hoops stream file format, or HSF, which is essentially a binary dump or a binary archive of the full contents of the Hoops scene graph, the whole Hoops database. So if you want to take everything that's in the current scene graph at a point in time, you can use the stream class, export, and write out an HSF. You can also have that go out to a HSF stream or buffers. It doesn't have to go just out to a file. The image class is for raster image I/O. We had covered the out of core or OOC format in the geometry chapter when we talked about shells and OOC or out of core point cloud usage of shells. The publish class is going to involve a connection with the Hoops publish product for publishing or exporting the scene to a 3D PDF. There's a lot of configuration capabilities available there. Hoops Exchange is the connector that bridges with the Hoops Exchange component. Exchange supports all the major CAD formats. They're reverse engineered, so it can import all those CAD formats. If you want more information on Hoops Exchange, you can go and look that up on the Developer Zone or on the TechSoft3D.com website. And the rest of the formats are fairly self-explanatory based on their names. Hopefully, SKP, SketchUp, STL, stereolithography, OBJ is another 3D type of format that is encountered fairly often. And the Exchange, Parasolid, and DWG formats, as noted, support a bi-directional integration via what we call the component hierarchy. So the component hierarchy is something that gets built during import of any of the formats supported by those modules. And essentially, this component hierarchy is a set of structures and objects that represent the structure of those models in memory. Depending on the format, there will be some generic types of components that might get created no matter what. For example, HPS component objects. There can be numerous ones of those. And in this example diagram here, if the Exchange component integration is being used, there will be Exchange-specific components for concepts that are specific to CAD files, such as captures, a CAD model, and so on and so forth. We can see other subtypes of specific items here, again, in section 9.3. For these formats, what's actually being stored in memory, independent of the component hierarchy, is when a Parasolid file is imported or a Parasolid set of kernel data is being built up. That Parasolid information, Parasolid geometric kernel information resides in memory. So the component hierarchy is providing a wrapper to that and giving you facilities to say, if I have this Parasolid entity, what is its corresponding graphical entity or entities that represent it in my 3D view, and vice versa, to facilitate editing, highlighting, selection, deletion, interaction. In the Exchange case, once any of the Exchange-supported file formats are imported, any of those CAD files are supported, there's a CAD format independent set of PRC data that is residing in memory. So the component hierarchy provides a bridge between the PRC data entities and the Hoops scene graph entities. And then finally, for the DWG format, which is the AutoCAD format from Autodesk, when you use the real DWG component, there will be ACDB data in memory, basically the entire DWG file format in memory, essentially. And the component hierarchy, again, provides a bridge between ACDB entities, IDs and whatnot, and hoops visualize. So when any of these are in play, there's two databases. There's the hoops visualize database, the hoops scene graph, and could be a Parasolid modeling kernel data, Exchange PRC data, or DWG ACDB data in memory. And the component hierarchy are separate sets of C++ classes that are instantiated that reside separate from both of those databases. We'll go through an import example. We'll take the stream format example, so for an HSF file. And the flow would be, we first set up an import notifier here on the stack. We also set up an import options kit, and then we'll set our destination segment. We've already had a my segment key predefined somewhere, most likely a model segment, probably. And then we call the stream classes, file import method. And that gives us back this import notifier information. We could use the notifier members to check import progress, which could allow us to put up a dialog box showing streaming progress. And in this case, we are pausing here until the HSF is completely done loading by calling import notifier wait. You might recall that that's going to be synchronous and blocking. We won't exit the wait until the import is fully complete. So that would be a standard piece of sample code to import information. If we looked at the other variants in this specific case for stream, we had called file import a file name, but you can notice further down there's a variant where we could have imported an array of incoming importing HSF buffers, so just a byte array of information. So there will be different variants of how to import or export as we go along. A good exercise here would be to customize one of the Run My Code slots in the sandbox to import an HSF from samples/data. The sandboxes already provide this capability out of box, but this would be a good exercise to just do by hand so that you can get familiar with this import code.